Hello, scholars. We're on video 2 in Unit 2. Last time we talked about displacement and distance and speed and velocity. Next comes velocity versus acceleration. All right. What actually is acceleration? How is it related to velocity? That's what we're talking about today. All right. So velocity is speed plus direction. Now that can be constant. I can be traveling at 50 miles an hour east and continue going that for hours and hours and hours. My velocity would be constant. It would be unchanging if I have the same speed in the same direction, but that's not always true. Velocity is going to change. It can change because the speed changes, or because my direction changes, or because they both change, speed and direction, at the same time. That's what we call acceleration. So when I've got constant velocity, my car goes at the same rate over time. Okay? If I change my velocity, I can go faster or I can go slower. And that would be a change in velocity or an acceleration. Now, if I'm going faster, that's going to be a positive acceleration. If I'm going slower, it's going to be a negative acceleration. Or I can change directions. That would be a positive velocity. I stop, and now that's a negative velocity. I've changed my direction. Or I can change velocity and direction at the same time. All these are different instances of acceleration. All right? Cool? All right. So let's actually define this. What are we talking about when we're talking about acceleration? All right? Acceleration is a measurement, just like velocity is a measurement of our speed with direction. Acceleration tells me how quickly or slowly the velocity of an object changes. So when my velocity changes, how is it changing? That's acceleration. Acceleration is a measurement of how velocity changes over time. If I'm speeding up, say I'm going from 0 meters a second to 10 meters a second to 20 meters a second, it means I have a positive acceleration. I'm speeding up. Or I can have a negative acceleration when I slow down. I can go from 100 meters a second to 70 meters per second to 40 meters per second and slow down. That's a change in velocity, but it's a negative change. My velocity is getting less and less each time. Right? Now, how do I measure this? How do I calculate it? It's a rate, just like velocity was change in distance over change in time. Acceleration is the change in my velocity over a certain time period. So my change in velocity divided by my change in time. My final velocity minus my initial velocity divided by my final time minus my initial time. This numerator is my change in velocity. The denominator is my change in time. Now, velocity is going to be meters per second divided by seconds. So my units are meters per second per second. I'm changing by 10 meters per second every second. Or a second times a second is a second squared. So you can say meters per second squared. Cool? All right. Not a very complicated picture, but acceleration is the decrease or the increase, the change in velocity. Cool. So, free fall. Book talks about free fall. We're going to talk about free fall a little bit more. And what you need to know about free fall is that objects don't fall with constant velocity. When you actually measure this, you're going to see that their velocity increases over time. Boom! Falls off a ledge. Gravity pulls it down. Gravity is a force. It causes it to accelerate. How fast does it accelerate? Well, objects in Earth's gravitational field near the surface of the Earth always fall at the same rate, which is 9.8 meters per second squared. In this class, we're going to approximate that to 10. 9.8 is almost 10. Within the range of our precision and accuracy, we're going to estimate it to say 10 meters a second. So, This means that every second it falls, its velocity increases by 10 meters per second. So after the first second, if it starts at rest, after 1 second, it's going 10 meters per second. By 2 seconds, it's going even faster. It's accelerating. It's going 20 meters per second. After 3 seconds, it's going 30 meters per second. At 4 seconds, 40 meters per second. At 8 seconds, 80 meters per second. So it gets faster and faster and faster as it falls until, boom, hits something and then it stops. Why? Because its velocity goes back down to 0. Right? This is called free fall. We're going to talk more about this in class and in the labs. All right, quick review. We're talking about what happens when velocity changes, the definition and mathematical equation for acceleration, and a little bit about free fall. At what rate do objects fall? You can find all this in section 3 of chapter 11. Make sure you have all the notes on each slide, a well-labeled picture, you've written down something you've heard, and 3 questions at the end. See you in class.